Welcome to Algebra 2 Final. Today is Tuesday all day, May 19th. I'm here with a bunch of delinquents that have decided at the last minute that they would like to learn some Algebra 2. Right now we're reviewing quiz number 5, which is actually 12 and 13 combined. They have asked to do the basics. This camera's on, the mic's on. Anything you can and say will be used against you in a court of law. Let's get started. So, we've got negative 6i quantity squared. What does it mean to square something? Yes, my studio audience is here. So we're going to get 6 times 6, which is 36, and even if it's negative, it's going to be positive 36 I squared. What happens when you get I squared? I squared is just negative 1, so we get 36 times negative 1, which is negative 36. Yeah, the key thing here, for those of you playing along at home, is that I squared is equal to negative 1. So whenever you get I squared, you just turn into a little negative 1, and yeah, they're timesing. So you're going to get negative 36, not 35, Emil. You don't add them. We're going to have two answers for this one. What do you square to get negative 9?
3 and negative 3.
Well, that'd be close, except that gets you positive 9. 3 and negative 3 will get you positive 9. What's going to get you the negative when you square it?
3i.
Yeah, it's got to be the I, right? 3i will come out to 9 times negative 1 when you square it. And negative 3i will come out to 9 times negative 1 when you square it. So yeah, these are our two answers. Hopefully on this one you know y squared is going to be equal to negative 3, right? I have to divide by 5. So what do we square to get negative 3? Well, definitely the root of 3 squared gets you 3, right? Yep, so this will get us 3 when we square it, either way, right? Positive or negative, it'll come out to 3. How are we going to get that negative sign, though? I. It's like Sunday school, the answer Jesus. Yep, exactly. Yep, when you square this, it comes out to 3 either way, and then you get that, and you get the negative 1. You have your I in the wrong spot. You can put it out front if you want. That's okay. All right, cool. Questions on that, because I know some of this is review, but some of this is teaching for the first time, right? It's outside. That's why I always put a tail on mine. The book, I just realized today, I was talking to Paolo about this. The book does theirs, if they have a number or I, they always do I, then the root. And the reason they do this is because they don't put tails. And so if you do like this, it's hard to tell if that I is in the root or not. And so they avoid it by just doing this. I do it by putting tails. That's something I started doing, and I've noticed a lot of mathematicians I've met do that as well. Great minds think alike. All right, questions about this, right? We need 3 squared gets us 9, and the I squared will get us a negative. This squared gets us 3, and the I squared gets us a negative. Cool. What does it say to do here? Add them, right? Because a lot of people see parentheses and they just start multiplying. That's down here, right? That's the next one. So if we're just adding them, we're going to add like terms. I've got 3 and I'm adding 7. That is 10. Amazing what a couple years without calculators will do. All right, 6i plus negative 12i is going to be negative 6i. And there you go. See, Milo is like crushing these now. This was crushing you earlier in the year, but look at you now. Growth. All right, what are we doing over here? Timesing? No, we're negating, right? One thing you can do to make it easier on yourself is you can just write it out like this. And what we're doing is we're minusing a 7 and we're adding a 7i, right? That negative you can think about distributing. If that helps you, then do that. If not, you'll just do it like me. 4 minus 7. What is 4 minus 7? It's negative 3. And then negative 7i minus a negative 7i really is adding, right? And that's where this comes from. That's going to get us 0, so we just get negative 3. Is that blowing anybody's mind? Are we okay? Are we feeling good? We feeling all right? Okay. Okay. I forgot to test the mic, but it does look like I'm getting signal levels, so hopefully it's loud enough. I can be louder. What are we doing down here? We're timesing. So we're going to get 10 and negative 12i squared, right? You're going to have to distribute. So we definitely get 10, but we're also going to get negative 8i, right? And when we distribute the other terms, 3i times everything, we're going to get 15i. Look at Milo. And then negative 12i squared. For those of you playing along at home, you might notice that I squared is negative 1, so this is just negative 1 times negative 12, which is positive 12. So I can actually combine these, right? And that's going to get me 22. And then these guys would combine to a positive 7i. Look at this. Milo was getting her butt kicked by negative numbers. Look at her now. Look at her now. She's leading the way. 93 Jordan. All right. We're timesing again, yeah? So we'll distribute. Big deal. 3 times everything. That's definitely 24 and 15i. Oh, look at that. Recovery. Negative I times 8 is negative 8i. Oh, she cannot be stopped. If the Wolves had you on their team, they would have beat Wemby. All right, this right here is 7i. But wait a minute, we also get plus 5, don't we? Because this is negative 1 times negative 5. That's positive 5. So we're going to get 29 plus 7i. All right, we got a lot of people in here. Are we all keeping up? Because I'm going kind of fast, but Milo's I think I'm keeping up with Milo because Milo's like this. Should I slow down a bit?
No.
We're chilling? Hercule isn't in here. Somebody did say Hurley. I think she said hurry. All right, we want to know the conjugate. Now, the conjugate means that you change the middle sign. So we get negative 8 plus 6i, right? And it does have to be that. For the complex conjugate, you do change the imaginary part. Because if you don't and you multiply them together, weird things can happen in higher dimensions. That's all I can say for now. So get in the habit. Most of the time you can get away with it. Speaking of which, on the next problem, you're going to get, or not the next one, but a problem down the line, you're going to have to do that exact thing. All right, cool. We're on 13-1-1. So we're actually knocking out 2 quizzes with the price of 1 right now. Or we just did 12. This is 13. So, guys, look, it's our old friend, the completed the square. It's done it for us because at this point we hadn't learned how to do it ourselves. We want to know when this equals 0. Here's how you do it. See this term right here? That's where my variable is. What do you add to 5 to get 0? So you know this part right here, the quantity of r plus 3 squared equals negative 5, right? Now the next question is, what do we square to get negative 5? What do you square to get negative 5? 5i would get you negative 25. Yeah. So this right here has to be plus or minus the root of 5i. Right? Because when you square that, you get 5, and then you square that, you get the negative 1, right? So here's the thing. What do you add 3 to get this? Are you ready? Are you ready? Are you ready?
Ready.
This right here is what you add 3 to get this. Are you seeing that if I add 3 to this, this goes away? Right? So check it out. If I were to plug this in for r, I want to make sure we're all on the same page here. If I plug this in for r, first thing I do is I add 3. That's gone. Then I square this. I'm going to get 5 times negative 1. That's negative 5. I win. And that's it. Same dumb crap over here. Let's see if we can walk together through this. What do we add to 16 to get to 0? Negative 16. So this thing right here has to equal negative 16. What do we square to get negative 16? Plus or minus 4i. When you square this, you get 16. And when you square this, you get negative 1, right? So this part in here has to equal negative 4 plus or minus 4i. What's going to have to happen? Well, we're going to have to double it, and we're going to have to minus it, right? And that's going to screw everything up. So here's what we want to do. We're going to add 1 and divide by 2. And there is your answer. There are other ways to do this where you put it like all above 2. So you get like this over 2. I'll accept that as well. They're the exact same thing. It's plus 1. Yeah. All over 2. Yeah, you can either divide it by 2 and get this. These are 2 terms, so you can either divide it by 2 and get this, or you can leave it over 2. I don't care. Notice that I really like this answer, because notice when you plug this in, the first thing I do is times by 2, right? Gone. Then I minus 1, gone. Then I square it, and I get negative 16 plus 16 is 0. Yes?
What was the difference between A and B that made this one more sense?
Because, great question. It's that 2 in front of here, right? If that 2 wasn't there, we need negative plus or minus 4i, and then we're just going to put a plus 1 in front of it, right? We would just use this if that 2 weren't there. Pretty easy, right? With that 2 being there, you have to think, okay, I need half of it, and then I need a plus 1, right? That's the idea. You can divide by 2 first if you want, but when you do so, you have to divide everything by 2. So that'll be x minus a half. Stop, one question at a time. X minus a half equals plus or minus 2i. You could do that and then add over the half, right? That works, but you have to do it to everything. Yeah, typically we save division for last because it makes fractions. So, yeah.
You either do a plus 4 and a plus 1 or plus or minus, and then over 2, can you either do that or the one you already have done for your...
Are you asking about these two?
Yeah.
Yeah, either of these work. Either works, yeah. All right, 13.1.2. We want to find the number a that makes this a true statement, a and c. Well, think about it. If I expand this out, right, I'm going to get x squared plus 2ax plus a squared equals this. So if that's true, look at this. What does a have to be? A's got to be 6. And notice that this and this are going to be the exact same thing, right? So if a is 6, what's a squared? So what does c have to be? Yeah. This is some baby mode stuff that's like more complex, writing it out this way than it actually is. Basically, if this is x plus 6 squared, we're going to get 12 and 36, right? Yeah. This, if we expand it the same way, we're going to get 2ay plus a squared equals all this junk. A's got to be negative 2. Briley is unstoppable. And if a is negative 2, that means a squared is positive 4. So what is c? Positive 4. Are you guys smell what I'm stepping in? We're going kind of quick.
No, I know it.
All right.
I feel like it's coming back to you.
Good, good, good. All right, now that should prepare us, like over-prepare you, honestly. Like I think we're kind of overcooked here. Prepare you for this. We want to write it as a square of a binomial. So we want to write this as this, a perfect square. So we definitely would need x and what number to get 49? 7. Cool. If we do that, what number are we going to get in the middle when we expand this? 14, so c is 14, right? If this were a square of a binomial, we would get x plus 6 quantity squared, right? But in order to do that, what would c need to be? 12, right? If you expand that out, you'll get 12 x's total, right? Is this really ringing a bell?
Yeah.
Like on God? Okay, okay, fair enough, fair enough.
I never forgot.
Say again.
Yeah, I said my bills are right.
Your bells are rung, okay? All right.
Bells never stop.
Find all solutions to this equation. So this is going to be kind of silly. This isn't factorable, so it's time to complete the square, huh? Remember when this was brand new? That's kind of fun. We definitely need plus 4, right? Everybody on the same page, right? We need half of this guy always. This is going to get us everything we want, plus a 16. Do you see a 16 here? No. So we definitely need minus 16 minus 1. Yep, and now we're actually, this is the thing, Briley, I think I was talking to you earlier. You're like, what should I do? Quadratic formula, complete the square to solve. And I'm like, oh, it's been a million years since you've done this. Normally we complete the square and we just use it for graphing. For this, we're going to try and figure out what does x need to be. So remember at the top of the page when we were solving those? We're going to do that here. So guys, what do you square to get 17? Because 17 minus 17 is 0. What do you square to get 17? Plus or minus the root of 17. Don't forget the plus minus. But they're going to make us add 4 to it. So congratulations, here's your answer. Do you see if I plug that in? I add 4, and then I square it. I get 17 minus 17 is 0. Yes. It should be minus 4. Or plus 4. It should be minus 4, yes. I'm going to slow down. What minus 17 is 0? 17. What do you square to get 17? The root of 17. But they're going to make us add 4. That's going to ruin everything. We'll just put a minus 4. Do you see how if I plug this in, the first thing I do is add 4? That gets rid of this. And then I square it, and I get 17 minus 17 is 0. It's because this isn't the first time you've seen it. Time is the most important factor in your education. Unfortunately, we cannot give you infinite of it. So I try to give you as much as possible by letting you extend your quizzes out. Things come back all the time, right? But yeah, time's the number one factor. It's the number one factor. You don't want this? Oh. Not while we're reviewing it. Maybe, I don't know. I'll answer that question later. I can't answer it right now. All right. That's fine. Go to work. What?
What's the point of subtracting 4 if the whole thing is equal to the root of 17? Like, if that's what you were saying.
So here's the idea. Do you see if I plug this in for x, the first thing it's going to do is add 4? That goes away, and then I square it and get 17 minus 17 is 0. That's the solution. That's what makes it equal 0. If you didn't have that minus 4 there, the first thing it's going to do is add 4. It's going to screw everything up, right? We're going to get this when you square it. It's not going to get you 17 anymore, right? So we need that minus 4 there to get rid of this. So when we square it, we get 17 minus 17. Is this clocking at all? Yes? Really? Okay, cool. Because words. Yeah. And I'll do it tomorrow, too. And if it's similar people who have watched the video, I can skip ahead and not do the same thing twice. For each of the following equations, complete the square. Guys, this is just complete the square. Should we go over these or no? I'm hearing yeses. I'm going to do it quickly. It is, if you know it. If you don't know it, it's not. So be kind, please. So, x. Well, we definitely need this to come out as 4, right? So what would I plug in to make this come out as 4? 7, right? That'd be one answer. Or the other answer would be, I could have it come out as, okay, hold on. Sorry, not 7, 5. Isn't 5 minus 3 going to get us 2 squared?
Oh, yeah.
Yeah, okay, cool. And then we also want positive 1, right? Because 1 minus 3 gets you negative 2 squared, which is 4. 4 minus 4 is 0. Yeah. Yeah, I don't know. I'm very, very tired. Over here, when we complete the square, we need 5 halves, which shouldn't scare too many of you anymore. That's good. It's called growth. Yeah, we all are. It's that time of the year. Because you can't. Well, I mean, you definitely could. You definitely could. Because this is an equation. I'm in graphing mode where it's usually not an equation, right? Probably, yeah. Probably to solve it would. Because then you just get a nice number here. It would be easier. I can do that in a second. But think about it. What do I square? I need this to be 21 quarters minus 21 quarters, right? What do you square to get 21 over 4? This, right? And you see how it's going to make us add 5 halves? Yeah, definitely don't want that. You'd rather have the 4? What do you say? How is this one different than the last page? Is that what you're asking about? The only difference is that it's really nice numbers here. So you could have said, oh, I need the square root of plus or minus 4, right? So let's do it the same way we did on the other page. Right? I need this. So when I square it, I get 4 minus 4, right? But oh no, they're going to make us minus 3, so here's our answer. Yes. And notice it is the same thing, right? Isn't this just going to be 2 plus 3 and negative 2 plus 3? Yeah. I figured. Sorry. Sometimes my brain jumps to what I see first instead of being consistent. Use the quadratic formula. Should we go over using the quadratic formula?
But every time I do these, I swear to something.
Bye. Oh, okay, cool. Make sure to leave a nice comment, like, and subscribe. All right, this right here. I was going to make a Me Undies joke, but I feel like that's like 6 years ago that was all on YouTube, the advertisement. Now it's like, what is it? The headphones? What are the headphones? Raycon, right? Sponsored by Raycon. All right, you plug in A, B, and C. What is our A value here? Try again. What is the coefficient? It's 1. 5, and 6. You plug them in. You do what it says. I cannot let you do that. What you should do is you should do it in study, and then on Thursday, right, when you're going to take the final, then you can do that in front of God and everybody. Does that make sense? I can't let you take a quiz on that. That's just not okay. I can't do that. All right, 13.4.1. This one right here. It says 1 root of our quadratic is 5 minus root of 6. What are B and C if this is, what's the other root, right? What's the other root? If B and C are rational numbers, what are B and C? So, bye-bye. This is one of our answers, right? This is one of our answers. What's the other answer? According to quadratic formula, what's the other answer got to be? Yep, conjugates, right? It's got to be. So, do you guys remember the sum of our roots is always going to be negative b over a? What is our a value in this one? 1. So our sum is just going to be negative b over 1, which is negative b. Now check this out. Here are 2 roots. Bless you. Here are 2 roots, right? We said these are our 2 answers. What's the sum of them? Let's add them together. What do you get? You just get 10, right? You just get 10. So what does that mean b is? No. Oh, yeah. Sorry. I'm sorry. I apologize. What did you say, Hadley? So b is negative 10. Now we know the product of our roots will always be equal to what? No, negative b over a is the sum. What's the product, you guys? Nope, just c over a. Now a is 1, so really it's just going to be c. So all we got to do is times these together, and we can figure out what our c value was. Let's go ahead and multiply them together. What's 25 times 25? Or sorry, 5 times 5 is 25. God, I'm tired. All right, 5 times 5 is 25. Notice that they're conjugates, so the middle's going to go away, right, if we multiply these? Yes. What is negative root 6 times root 6? Negative root 36. What's the root of 36? So we just get 25 minus 6. That's going to get us 19 for C. All right, and that's it for the basics for 12 and 13. Okay, that last one, little something, right? Yeah, that's okay. We're just using sum and products. If you guys don't know that stuff, I'd review that first. That's technically last semester, some sum and product stuff. It's a throwback. It might or might not, I don't know. Aubrey. The best strat is to study first the things you know. That way you can make sure that you're not going to miss those. And then from there you want to be like, what things could I potentially learn? And then you want to add on the top of it. That's what you want to do. I would definitely study tomorrow or tonight the things you know. And then tomorrow I would study the things you want to know. Does that make sense? That's how I do it. I always study in 2 days for that reason, right? Make sure you're not messing up the things you do know. And then 2, see if you can learn some other things, add on to it. But here's something you need to understand. Time is the #1 factor in learning and understanding, and you're not going to be able to learn a ton of stuff in one day. It's just the reality. I'm sorry to say it. It's just not possible, okay? So you need to set modest goals for day 2 of studying. Does that make sense? The day where you're trying to add on more stuff. You're not going to be able to add on a ton. You're going to only be able to add on a little. So my goal for everybody should be do as many of the basics as possible. That way you're guaranteed the pass, right? That's what you should want to do. If you have loftier goals in that, if you're one of those people that has done a lot of the intermediates, then obviously the basics are kind of a given, right? Make sure they're solid. Make sure to study a little bit, but mostly focus on like the intermediates around there, okay? All right. Do we want to do the intermediates on this or no? My advice is, whatever you have already learned, whether it's all the basics, all the intermediates, or none of the basics, whatever that is, you need to make sure that you solidify that, and then in day 2, you should try to add some stuff on that you've never proven you knew before, right? That's what I'm asking. That's what I'm asking. Do we want to do basics on the next one, or do we want to keep going on this one? For 13? So skip the 12s? Okay, I can do that. All right, solve each of the following equations. This is very similar to what we were doing earlier. What do you square to get 3? This, right? Oh, no, they're going to make us add 4. There's our answer. We fixed it. There we go. Right? When you plug that in, doesn't it work? Cool. Over here, what do you square to get 18? Guess what? It's this. But oh, no, they're going to make us minus 9. Okay, we'll just put a plus 9. Bye-bye. That... Right, which is why you need to be in class learning it. What we are doing right now is reviewing. That's why it's clicking so much better, because it's a second refresher on stuff you already spent the time working on. You guys don't want to spend time in class, but you will spend time on the quizzes eventually doing stuff. And now that's why it's clocking better to you guys. That's why. That's why. But yeah, you guys are capable of doing this stuff. You really are. All right, this one. A has got to be equal to negative a quarter, or negative a half, I mean, right? Do you guys see that? Right? That means C is going to be positive a quarter. Well, this thing right here, right? When we distribute it all out, we're going to get 2 of these guys, right? Oh, hold on. Thank you. I should go slower. 1/64. So negative 8 twice, negative an eighth, right? You're going to get 2 of those. If I get 2 of those, isn't it? All right, I'll slow down. I'll slow down. Sorry, I was trying to go fast because a lot of people don't want to see this, but apparently we do. Here. X plus a quantity squared equals x squared minus x over 4 plus c. So similar to the last one that we did that was similar to this, except now we have a fraction. When you expand that, you get this. What does A have? Briley left, so Briley was really cooking on these. What do you double to get negative a quarter? That's what this is, right? What do you double to get negative a quarter? Negative 1/8, right? Because in 2/8 is 1/4. So that means A squared is 1/64, right? And that's the same thing as C. Better? Okay, cool. Apologies. Let's see if we can do that same thing here. Okay, we need an eighth, half of this, right? Right? It's kind of like completing the square. We need half of that, right? That's what A is. What's half of a seventh? Yeah, a 14th. Very good. So A would be a positive 14th, 1/14th, because half of 1/7 is 1/14th. If it was negative, we'd use negative. That means A squared will be 1/196. So that means C is 1/196. Because 14 squared is 196. 13 is 169, right? 14 is 196. They're kind of reverse of each other. It's kind of fun. All right, yeah, nice. This guy. If we were to complete the square, meaning make it a perfect square, we would need what here? 4 is close. I think you mean a quarter, right? A quarter squared is 1/16. Yep. Mm-hmm. Yep. So C would be, so if we were to do that, C would be 2/4, which is a half, right? Am I, yes? Quarter? Yeah. If I expand this out, x squared plus a quarter x plus quarter x plus, it's not. Half is this guy, remember? Yeah. Do you see how when I expand this I get 1/16? Yeah. Words. Find all the solutions to this. Guys, this is a complete the square and solve. So let's factor out a 2. And what we're going to get after we factor out a 2 is this. Do not do what Eli and Esteban do and try to complete the square before factoring out the 2 all at once. Like, don't do that. First, factor out the 2. Everybody cool with factoring out the 2? Now let's complete the square. We need half of 4, which is 2, right? And then we get minus 4 and minus 5 halves from earlier. You can totally get commie denomies and combine those if you want. But remember the thing everybody forgets. We have to distribute the 2 back to everything, right? So that's actually going to take care of our denominator. So I think we're going to be cool if we do this. Minus 8, minus 5. And now here becomes the question, which is how Briley wanted to solve one earlier. So shout out to Briley. And we're here. Is everybody seeing how we distributed the 2? We got all our junk? Yeah? Okay, cool.
Don't flip the page yet.
Okay. What do we square and double to get 13? I'm going to answer that question. Let's see if you guys can see why this is true. Do you see if where my fingers are, we plug this in?
Yeah.
Should be this, shouldn't it? Yeah, it should. Yeah. Here, I'll write it like this. Do you see if we square this, we get 13 over 2?
Yeah.
What's 13 over 2 doubled? 13 minus 13 is 0. So that would be great if this was just r, but they have a plus 2 here. We'll just put a minus 2. We'll be all right. Again, check this answer for yourself. If we plug it in, first thing we do is add 2. Then we square it. Then we double it. 13 minus 13 is 0.
Are you gonna scan these tests on a platform?
Am I going to... Oh, have I done that in the past where I scan this and send it?
I don't know what you're doing.
Yeah, I definitely can. All right, should I continue doing 13s, intermediates?
Can you just skip to the end of
It's more completing the square. What ones did you want to talk about? Quadratic formula?
All of these gonna be on the final?
No, if it's... this is not a test. Remember, this is a quiz because we didn't have a test on 13 and 12. So most of these are going to get cut out.
why did Eli just find this?
I don't know. Bye-bye.
Would it be smart to only do the basic ones for all of the...
It depends on who you are, so it's hard to answer that question, especially on a microphone. It depends. What are your goals?
It depends on who you are on whether you pass or fail.
No, it depends on who you are and what your goals are. Guys, if you are a person who's like, I want to get an A in this class, but only ever do the basics, are you ever going to get an A? No. You're going to get somewhere between a 70 and a 60 because you're going to get most of the basics if you shoot for the basics, but probably not all of them. If you get all 7s and 1 6, it's going to average to 6 point something, right? That's how math works. So if you want to get somewhere in the 80 or 90 range, you probably want to go for the intermediates. If you do all the intermediates perfectly, you will get exactly a 90.
But don't you have
Anything less than perfect on the intermediates, you'll get an 80 something, which is why you should probably be doing some of the advanced problems if you want to get an A. That's how averages work, okay?
That's not good, Mr.
That's how averages work. I knew it. I said this to Camden earlier. I don't think anyone understands averages, and I think that is why we are confused.
So on the test, I should focus more on the intermediates. What? Okay, goodbye. Never mind, I'll figure it out.
You should focus on proving the math that you know. That's it. If you do that, you can't fail. Like, that's it.
I don't want to fail, I want to get an A.
What if I try my hardest and I do so
If you try your hardest, let's no. Stop. No, this is my point. This is my point. If you try your hardest, it doesn't matter what happens because you did your best, right? And you can't change it either way. That is my advice to everybody. Everybody should do their best. And if you did your best, whether you fail or not, which you won't, but if you fail and you did your best, then what more can you do?
people are saying, what if
Problem solved.
what if I do my best? You don't think that is good enough?
No. That's not what this is. This is not my opinion, man. What I'm saying, focus with me. If you do your best and your best is god awful, you still did your best. There's nothing more you could have done. So why am I giving you advice?
You're gonna give a bad grade.
Right, but if that's it, all you could have done, then what are you worried about? The only reason people should ask, should I do this, should I do that, is if they're trying to do less than their best but still get away with it. If you just do your best, then just do your best and you have nothing to worry about. Do you understand what I'm saying? So this is not a matter of language, apparently. Okay, cool. If you just do your best, no matter what happens, you did your best. That's all that can happen. That's the easiest answer.
But don't give me a bad grade for doing my best.
No, I'm going to give you a fair grade. Whatever it is fair.
But, no.
It's not vibes, man. If you do your best and your best is not good enough, then that's just how it is.
But I didn't try
Hi.
at all in Algebra 1.
Do you understand? No. Do you understand this logic?
I'm trying to
If I do my best, no matter what happens, I did my best. And so there's nothing more to discuss, right? You can't, like...
Freshman year, Algebra 1, I didn't try at all. You gave me an A on
I didn't give you an A. You earned an A. Freshman year algebra 1 was easy. Girl, I promise you.
semester that
I promise you. Okay?
do anything freshman year.
You didn't need to because it was algebra that we had to treat like pre-algebra. Sorry. Yeah, I know. What do you want from me, okay? What's up? Raised voices, yeah.
Correct.
Just
Coming out
do
of
your
the
best.
library is
Yeah.
out of-
Just do your best. If you do your best, you have nothing to worry
I
about.
was just trying to talk and I was getting interrupted, so I got a little bit angry.
That's because what you're arguing is irrelevant. You just do your best, and whatever happens, happens, man. You can't do better than your best.
What needs to happen is I need to get an A.
The getting an A portion, the thing that you need to do is learn, and that's stuff that has to take place during the semester. It's put it this way. You're all musicians, right? You're all basketball players and stuff. You gain confidence from the practice room and on the court when you're practicing, right? And then when it's game time, you just have to forget all that stuff, let it go, and just let the ball rip, right? That's what you got to do. You just got to let it rip. All that confidence and everything you did before, okay? All that, okay, comes beforehand. Finals week is game day, okay? There's no like, no, man, that's all for the semester, right?
I'm not doing that.
Okay?
Please, for the love of God, both of you go,
Yeah.
okay. As long as
I'm
it's
gonna
okay.
do that on the final.
Alright, next time, right before I throw, I'm gonna
If you don't want to do bad in the final, if you don't want to do bad in the game, if you don't want to have a bad performance, you have to do it in the practice room earlier, right? Or then what are you worried about?
You're still gonna give me a bad grade.
You're gonna get whatever you deserve.
But I think I deserve more than you think.
What you think doesn't matter.
Whoa.
What's up?
I get a really good grade on the final. Is that gonna bring?
It's gonna drop your grade to a 0. Everybody knows this. If you get a really good grade in the final. What kind of question is this? Will my grade go up if I get a good grade in the final? Yeah, if it's higher than your current grade.
How much will it go
Do you
up?
understand averages? If you have a 90 in the... Oh, I know, this is the problem. If you have a 90 in the class and you get above a 90 on the final, it will bring your grade up. The higher it is above a 90, the more it'll bring it up, okay? But if you get something below a 90, it has to drop it. That's how averages work, right?
You can
Okay.
give me an A on it?
No.
If you earn an A. if
We
you
could study right now and you could earn an A. How about that, right? Okay.
I've been studying for
I've been studying.
4 weeks. I've been skipping practice.
Okay, then what do you got to worry about?
Everything, because I'm already give me a B again. They gave me a B last semester.
Can you explain this better than I can? Please try.
We gotta, if I'm in a damage control and help the yelling that's happening and the frustration I can see across your face, what is this is gonna sound mean, but I don't mean to be mean, what is your problem? Like, what is the actual, I'm not trying to be mean, I'm just trying, what's the root? What is this happening?
He gave me a B last semester on my final.
Because you got to be.
No.
B.
No. Okay, what if I
Yeah,
try
I
harder
mean,
than
you-
last semester, but I still only get done like some intermediates and some basics, or actually all the basics and some intermediates.
Okay, all the basics are 7s. Intermediates are 9s. What's between a 7 and a 9? An 8, which is a B, which is what you got last semester. No, you can't get a 10. Can you get 7s? Can you get 70% and 80% and have them average to 100%?
No.
No.
Aubrey said yes.
No, you can't. If I had a bunch of 7s and a bunch of 8s together and I divide by the number of whatever, you're going to get somewhere between 7 and 8. That's how averages work.
A lot of intermediate, but more basics.
How much work did you put into the B that you got first semester?
I got an A for my overall.
Okay, so how much work did you put in to get the B that you did?
I don't remember.
Okay, we'll put in that same amount of work and you'll get the same amount
Well,
of.
I've been putting in more work.
Girl.
Okay.
Girl, let's stop with the vibes, okay? Your question was, what if I get a bunch of 90s and I get a few 70s? What will that be? It'll be slightly, yes, you said basics, intermediates.
No, I said more 70s, but a lot of 90s.
Okay, think. Any amount of 90s and 70s is going to be somewhere between 7 and 9. Does that make sense? If you get a lot of 7s, it's going to be closer to 70. If you get a lot of 9s, it's going to be closer to 90, right? If you get the equal amount, it's going to be an 80. This is basic math.
No.
Oh my God. Yes, it is. It's just averages.
I feel like you're almost just arguing to argue at this
I think so too.
I am. I don't want to be wrong.
Well, I got bad news. You are wrong. Okay, cool.
Is disaster averted that I can leave now and not have to?
No, we do this every day. It's okay. What do you want to do now, studio audience? Bye. 16? 15. I'm hearing 15. I heard 15.
Abigail.
I don't have 15s yet. I don't have 15s yet.
Wait,
me go grab
15 check sheet? I need that. We didn't do 14. I've been asking for that for the past 3 days. 14. He just mouthed on my himself as he walked out of the room. Did you see that? No, wait. Well, as long as I get a good grade on the final, I don't care what
not gonna go up 2 letter grades by the time. Oh, wait, forget what I need to say. Pepperoni breadsticks. Okay. Okay, guys.
Yeah, everyone shush, especially Paula.
Hi, are you, is the oven working again? Oh, it is. Okay. Can I place, a delivery right now? We were told that we could call back 4:15 for a delivery. Okay. Well, never mind then. Okay. It's okay. Bye. I'm gonna kill this guy.
Hey,
We're like.
I'm recording live to YouTube, and they will block my channel. And if that happens, Milo's gonna be very upset because she wants to watch this. All right, so 15s are what I'm hearing, yes? 15s?
I guess. No, I wanna do 14.
14. We can do 4 times. If I'm happy with it.
Wait, and
I need 14.
I don't know if I have 14s. Didn't I pass out all my 14s? Did I not pass out any?
No, I got one.
What happened to them? Oh, because no one raised their hand for them, so that's why we don't have any.
Why raise my hand and give me one?
Oh my god. I have 114 for myself. Does anybody else need a 14? Guys, we are wasting so much time.
What are we doing?
I'm just gonna do it. I don't have time to print out stuff you guys didn't raise your hands for. This is why you print 10 of everything. All right, guys, it says graph the quadratic equation. We gotta complete the square. We need 5. This is gonna give us 25 and we don't want it. Everybody cool with this?
yeah.
That means our vertex is gonna be whatever minimizes this.
-5, -2.
Yep, that's right. So our vertex is going to start here. 1, 2, 3, 4, 5, down 16. And from there, it's going to grow just like this. All that extra junk is really just to help us find our vertex. So if it's going to grow just like this, we're going to pick numbers for x, and it's going to grow in the y direction. A lot of you guys just do this in your heads now. Whoops, 2, 3. So let's go ahead and plug this in. What happens when you plug in 1 or -1? You square it. You get 1. That means 1 to the right or left, because that's an x value, is going to go 1 up, because that's a y value. So we start here. 1 to the right is 1 up. 1 to the left is 1 up. 2, when you plug it in, you get 4, right? So that means 2 to the right or 2 to the left is going to go 4 up. Again, you start from the vertex. 2 to the right, 2, 3, 4 up. 3, when you square it, is 9. So 3 to the right is going to get you 9 up. Here's 4, 5, 6, 7, 8, 9. And as we know, it's going to be symmetrical, right? This is interested where it's equal to. So that means we're just going to draw a solid line, because any number you plug in is going to get you some point either on this half of it or this half. Ta-da! That's all of it. Any number you plug into this is going to get you a number on here. Questions on that? Complete the square, find the vertex. Maybe. Does anybody want to do the next one? Skip the circle one?
Yeah.
Okay.
That's not a good idea. You don't want to do
Emily, we should do the circles. Emil, what we have to do is complete the square twice. So first thing I'm going to do is rearrange this to get all my x's near each other and our y's near each other. And let's complete the square twice. That means we're going to need -4, right? Which, of course, is going to give us 16. We don't want that. That'll change the problem if we just write that. And then here, we're going to need what number? 6, which gives us 36. So we need to write -36, otherwise we change the problem. After we complete the square, we're going to move everything over that isn't in these two binomials. We're going to do that by adding. So we're really adding 52 to this. So that's going to be 110 plus 11, which is 121, which is very convenient because
Where did you get 50? Oh.
I added 16 and 36 to 69. Nice. Which is convenient because, you know, if we were to root this, we would get the distance formula, and that will give us the distance of our radius. What is the root of 121? 11. So our center is whatever makes this equal 0 because it's going to give us a distance of a point between our center and itself. How far is the center from itself? 0. So how do we make this 0? Well, these got to be 0. What would I plug in for x? 4. And what would I plug in for y? So our center is at 4, -6. That is the point that is 0 away from the center. 4, -6. And then we're going to go a radius of 11. So that means you go up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You go 11 in every direction. This is 6 plus 11 is 17. That's going to end up right there. Or no, that's 4 plus 11. It's 15. It's going to end up right there. This is already down 6. So if we go 11, it's going to be at 17. That's right here. And this is already 4. So if we go 11, it's going to be 7 more in this direction. 1, 2, 3, 4, 5, 6, 7. And there is your circle. So Emil, we complete the square twice. Our vertex is going to be what makes this 0. And after we move everything over, you root this to find your radius. You just go in every direction. Emily. I can't use your real names because it's online. Bripley is what I will call you. I'll just make that up on the spot, right? We'll just call you Bripley. No one will actually know your real name. We're going to call you Koa. Another fun thing you can do, because they can't see, they can only hear. Die, Koa! Oh, yeah. In Minecraft. All right, should we do this? Yes, 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 yes. Guys, first off, is this one going to open up or down? Or, sorry, let me say it again. Is this one opening positively or negatively?
Positive.
Good. So, is it opening up or to the right?
To the right.
To the right, because it's growing in the x. Good. So it's going to go to the right. So we know it's going to be like this. Good to do that first. That way you don't do this whole thing and then graph it wrong, right? So let's go ahead and complete the square. We're going to divide by 4 first in order to get this leading coefficient to be 1. And then we're going to complete the square. Emil, what is half of 5? Very good. 5 halves. And the reason I like 5 halves better is because I know what the square of 5 halves is. I don't know the square of 2.5. So the square of 5 halves is 25 over 4. Don't want that. And you could get kami denomies right now, right here, right now. But why would you? Because you're going to times everything by 4 by moving that over, right? And that's going to get rid of your fractions. Notice you do not put the 4 in here. No, because that would mean you're then squaring the 4, and that's not what this is, right? We're just timesing by 4 once, not twice. If you times this by 4, you get -25. You times this by 4, you get 16. That means our vertex is going to be where y is -5 halves, not x. Do you see y will be -5 halves? Do you see when we do that, this all becomes 0, and then we get 0 minus 25 plus 16. That's really minus 9, right? So there's our vertex, -9, -5 halves. Do not flip these because you're going on autopilot. See, that's a y value, Emil? Yes? Okay. -9, -5 halves. 1, 2, 3, 4, 5, 8, 9. -5 halves is here. -2.5. From there, what we're going to do is it's going to grow like this. X equals y, 4y to the, or 4y squared to the second, I guess, is what I was trying to say. We're going to pick numbers for y and see what happens to x. All right, everybody. If I choose 1 or -1 and I square it, what do I get? When I choose 1 or -1 and I square it, what do I get? 1. But then it's going to times it by 4. I'm going to go, and then here's going to come out 4, but then I'm going to times it by 4, I'm going to get 16. Here it's going to come out 9, which is 36. She's awake. She's cooking. Her brain is on. Shout out to Christina if you're listening right now. Okay? So what this means is that whenever we go up or down 1, because it's a y value, we're going to go right 4 because this is an x value. So up or down 1 goes right 4. 1, 2, 3, 4. I told you it opened this way, right? Always go from the vertex, no yawning. 2 up is going to get 16 to the right. So 2 up from the vertex is 16 to the right. So there's 9, 10, 11, 12, 13, 14, 15, 16. And it'll be symmetrical. Obviously 36 ain't going to fit. Again, we're interested where it's equal to, so we're going to draw a solid line. That's where it's equal to. Yay! We want to know what the axis of symmetry is. Well, it's this little line, isn't it? This little line of mine has the equation y equals -5/2. Because if you notice, every point on this dashed line is something -5/2. 0 -5/2, 1 -5/2, 2 -5/2, 3 -5/2. Y is always -5/2. That's the equation of that line. Wow. Wowee. Emil, do we feel like a little bit of studying and some practice? We are feeling a little bit better? Yeah. I'm doing the best I can. 1415. Yes, no, yes? Only part B.
And C.
There's A and B on this page. 1415.
What the heck are you looking at for a different position?
This is the test.
Oh. Can I get that out?
For those of you watching and listening, this is the best they ever are, actually. This is their peak. This is best case scenario.
Alright, I'm there.
All right, are we doing A or B?
Goal.
All right, vertical axis of symmetry means this. Paula, I apologize. Vertical axis of symmetry means that we're going to have either this type of parabola or this. So is that y equals or x equals?
Y equals.
Y equals. We just did an x equals, right? Y equals is this. So it's going to be y equals a times something with x, right? Now we know the vertex is 7, 2. So what does that mean goes here? If the vertex is 7, 2, that means 7 for x makes this 0. So what's got to go here? -7. And when we plug in 7, everything should go away except for 2. So there you go. There's what our equation is going to look like. Now, this represents all the possible parabolas you could have at that exact vertex, right? What we want is one that goes through 12, 7, meaning that 12 for x should get us 7 for y. So if that's the case, we want one that has an a value that will get us 7 when we plug in 12 for x. So let's make sure we get an a value that does give us 7. What's 12 minus 7? Try again.
4. 5.
Let's let them use calculators from 6th grade onward. What's the worst that could happen? 12 minus 5 is, or 12 minus 7 is 5. 5 squared is 25. What's the worst that could happen? All right, fam, what do you add to 2 to get 7? So what times 25 gets you 5? 1/5. So we know that this has to be the equation we're looking for. Notice that when we plug in 12, we do get 7 now. That was the whole point of that, right? Same num crap for this one, except it's horizontal, so it's going to be x equals, right? Guess what doesn't go here? -7 does not go here. Why does -7 not go here?
Because it's an x equals, not a y equals.
Right, so what are we actually going to put here?
The Y value is
-2. And over here we're going to put +7. We know that 12, 7 is supposed to come out of here. That means 12 for x, 7 for y, right? 12 for x and 7 for y. Do not goof that. 7 minus 2 is what?
5.
5 squared is 25. We get something very similar. She was so excited. All right, guys, what do we add to 7 to get 12? We didn't know this earlier. 5, very good. And so A is going to be 1/5 again. Did I goof this somehow? Y is 7, 12 here. No, I think we did fine. It just happens to be that way. 2, 7. No, I think we did it, right? This is 5 squared, yeah. It just happened to be that way. That's kind of crazy. X equals 1/5 y minus 2 quantity squared plus 7. Is it always going to be just these two reversed? No. It just happened to be that way. Yeah, one's going up and down, one's going right and left. And this one's going to the right, this one's going up.
Wouldn't that be the same for all the functions?
What's the same?
Like the coordinates. If the coordinates are the same, wouldn't
If these are the same coordinates for both, it'll just be this but flipped. No, sometimes this will be a different number. It just happened to be that way because 7 and these numbers work together really nicely to get 5 either way. Yeah, could have been different. Could have been different.
Did you change the 15
We can if you want.
I want.
Does everybody want 15?
Wait, what did you do?
Paola says yes. I want cheese so then I can see what I need.
They're online. Go on Classroom.
Your problems that you need right now anyway we're reviewing, so just be quiet and do the problems.
Samantha, who are you? What significance do you have?
Chill. 15. Basics, yes?
No.
I've done too much basics in the last week.
Fantastic.
Or just 15 in general.
15 intermediates? Yeah. This one?
Sure.
Guys, right now you should be able to see one of your crits is 3, right? Because this thing is twice. Notice that this will always be positive, but for those of you playing along at home, I will factor everything and I won't use any shortcuts. But yeah, this will always be the same, so it'll always be positive, right? If it comes out double negative, it's positive. If it comes out double positive, it's positive. Whatever. We'll pretend we don't know that. What are our other critical values? R equals what?
5/2.
And? Very good. So let's go ahead and draw a little number line. Put them in order. So it looks like -5/2, +5/2, and 3. All of which, if we plug in, give us 0. And do we want it to equal 0? No! See how it says greater than? So we need to find out when this comes out positive. So let's pick a really negative number like -69 million. If you plug that in, you get negative answer here, negative answer there. -69 million doubled -5 is definitely negative. -69 million doubled plus 5 is still negative. So if all 4 come out negative, what is a negative times a negative times a negative times a negative? It's a positive. It worked. Now pick a number between -5/2 and 5/2.
0.
Thank you. Negative, 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 positive, yeah?
For some of the quizzes that I've taken, 0 works, and then any other number doesn't work. Like, it gives a different...
You done goofed. You done goofed. It's like when you're graphing a line and you plug in a bunch of numbers and then you plug in one number and then you get this and you're like, well, that's weird, right? And it's like, no, you goofed on that point, obviously, right? So you goofed.
I don't know why.
I promise you, you goofed.
Choose any other number than 0 every time.
0 cannot hurt you.
0 does...
No, if 0 isn't working, the problem isn't with 0, the problem is with whatever you got.
That's not good.
Or maybe you're not good at plugging in 0. Maybe you're not seeing that 0 minus anything is negative, 0 minus anything is negative, 0 minus anything is negative, 0 minus or plus something is positive. I don't know. But 0 should be your friend. All right, so 0, when you plug it in, you get negative, 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 positive. That comes out negative. We don't want it. Between 5/2 and 3, right, this is 2.5. So what about 2.75? Negative, negative. You double 2.75. That's definitely more than 5, right? Because we're doubling more than a half, 2.5, right? So that's positive, that's positive. So negative, negative, positive, positive comes out positive. And then this guy over here, Probably it's going to be colored in again because it's a multiplicity of 2. That's usually what happens with these things, but let's double check. If I plug in 4, positive, 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 yep, works. When it's a multiplicity of 2, it almost always does that. I wouldn't bank on it, just check it, but don't be weirded out if it does. Cool, so that means x exists between negative infinity and negative 5 halves non-inclusive, unity, 5 halves to 3 non-inclusive, unity, 3 to infinity non-inclusive. Do we want to do the next one? Want to do the next one? Okay. I know. They didn't print earlier because I don't know why. Or maybe I have them. I don't know. But they didn't print earlier, so I hit print again, so they should be done. What about these guys? We want to do any of these?
No.
Minimum, maximum, complete the square?
We can.
Okay, cool. 1541. We want to find the minimum value of this. This is a parabola, right?
Yes.
Where will the minimum value be?
Very bottom of the vertex.
Which is the vertex. So to find the vertex, we got to complete the square. Ripples. I'm going to need half of negative 8, which is negative 4. And that's going to give me what number when I square this whole thing? 16. Don't want it. So we're going to end up with this. That means when we plug in 4, we're going to get the smallest possible value. What's the smallest we can make this thing? Notice this will always be positive, right? So the best we can hope for is this comes out to 0. What's 0 minus 12? That's the lowest it'll be, right? Our vertex is at 4, negative 12. So if you think about it, way down here, negative 12. That's the lowest value, okay? Now we want the maximum value. Why is it asking for the max? Oh, because it opens down, right? So the max will be the vertex again. Let's go ahead and factor out the negative 4. Please, for the love of God, factor first and then complete the square. You guys like to do this all at once, and it leads to disaster. Half of 10 is 5. We got to subtract 25,
Can't see it, it's off the page.
and we get this. When we distribute, we're going to get this. Do not distribute that negative 4 into here. This becomes positive 100, and this becomes negative 36. Looks like we're going to get 64, right? That's what this comes out to. So the max possible value, since this will always be negative, right? See this? Is to make this 0, and we get 0 plus 64. That'll be our max, so 64 is the max. Right? Negative 5, 64 is your vertex, so 64 is the max. Here we got to factor out a third, which always makes everybody really, I don't know what the word is, but they don't like it. We need 6x here. Here's how you know. Here's how you know. You know you can always distribute it back to check, right? A third times x squared, that's that, right? Mm-hmm. A third times 6, that's definitely 2x. 3 times a third gets you 1. We need 8, not 18, 27. Do you see how if I distribute that back, I times by 1 and divide by 3, I get 9. So yeah, we need 27. Let's go ahead and complete the square. We get this. Do not forget to distribute that 1/3 back. If you don't, you're going to get the wrong values. Yeah, bad news. 6. And at what value of x? At x equals negative 3. I don't know why this one asks for the x value. But yeah, when x is negative 3, the whole thing becomes 6. Okay. 16 now? Okay, cool. I'm going to go grab 16s. They should be done printing. notice they say quiz, but remember it's the one that I had to cross out and write test on. They're not in color, I apologize. So this is really a test. All right, so 23 minutes and counting. What should we go over? Paolo, you got any requests? Which ones?
Okay, Paola.
Hey, she's been waiting patiently. Which ones? Oh, she's not ready. It's your time to take a swing, and you're not ready. Please don't ask about 16.54. I don't want to have to explain it in the time we have. Was that the one? Answer's 9. Does that help you?
Is that the same thing for all?
I never change the numbers because it's too complex to change them, and nobody ever does them. So it's 9. It's not on the final.
Dang it!
Why is she smirking like that?
You should have
You
people
would
go.
follow this. It's a little jolly.
Alright, 16.55, go.
On the advanced?
Yeah.
All right, cool.
That's what Paola wants, right, Paola?
All right, so friends, Romans, countrymen.
Pressured.
Here's what we're gonna iterate. So what's gonna happen is we're gonna have to do like plug in a bunch of different things to eventually get our answer, okay? So we know f of 1, 0 equals 5. Okay, cool. That means we're plugging in 1 for x. So let's keep our stuff organized. We plug in 1 for x. And then we get f of, what's 1 minus 1?
0.
Thank you. And then x is 1, y is 0, right? So what's 1 minus 0?
1.
And we're supposed to have this equal 5. So what does that tell us about f of 0, 1?
It equals 4.
F of 0, 1 must equal 4. Let's go ahead and write that out. We know it equals 4. We know in this case we get 0 plus f of, and again, we want to find 5, 2, right? Ooh, actually, you know what? Hold on. I think it might be faster if we do it this other way. Here, let me show you a faster way.
Are you kidding?
No. Let's do a faster way. Let's start with 5, 2 and work our way back. Yeah. Let's start with what we want to know. F of 5, 2. Well, that's going to be 5 plus f of 4, 3. You dig? Yes. F of 5, 2 is going to be 5, 4, 3. 5 for x. 5 for x gets you 4. 5 for x, 2 for y gets you 3. Yeah? Cool. So to figure this question out, to know what it equals, we need to know what f of 4, 3 is. Okay, cool. Well, what is f of 4, 3? Well, f of 4, 3 is 4 plus f of, well, if x is 4, we get 3. And this becomes 1. I'm going to pause. Are we seeing where I got those numbers from?
Yeah.
4 minus 1, 4 minus 3, right? So in order to know that, to know this, we need to know f of 3, 1. So let's find f of 3, 1. Well, f of 3, 1 is going to be 3 plus f of 2, 2. So in order to know that, in order to know this, to know that, the thing we really care about, we got to know f of 2, 2. Let's see if we can find f of 2, 2. F of 2, 2 is 2 plus f of 1, 0. Wait a minute. We know f of 1, 0. What is f of 1, 0?
5.
This is 5. So that means f of 2, 2 equals what?
7.
And if f of 2, 2 equals 7, that means this will equal 10. Are you following me?
Yeah.
And if f of 2, 2, or f of 3, 1 equals 10, then this will equal 14. And if f of 4, 3 equals 14, this will be 19. You win. How you like that? Advanced problems aren't hard. It just means you have to actually know your crap. Hi. 16548 on the final, so you get it for free. But you get it for free because it's not on the final.
So which ones are the final?
I don't know because I haven't made it, but 5-4 isn't going to be on the final because it wasn't on the test. I have made the tests. I take the test, I throw them on the final, and then I delete questions depending on what class it is. This one's not going to be on either, though. This one right here isn't going to be on either.
I'm gonna do every single 15 because I feel like I've done every single
Okay.
5 minutes.
Cool. All right, show and tell over. What would you like to do now?
17.
17? Nobody wants to see a single 16.
No, I do want to see a single.
Okay, well, take your time. We have 17 minutes.
I thought we went to 6.
Oh, no, we have an hour and 17. You're right, yeah.
Yeah, I was gonna 6.
It's not.
Get food?
Can we do 16 on 4?
I think you have to call back and order at 5:30. Isn't that correct? No, 6.
What?
He said delivery start at 6.
No, 5. Why does everyone remember? Who's the speaker in this room? Wait, can you hear me?
No, I did not. What?
16 on 4.
1-4. And that's on the basics? Nope, intermediates. All right, cool. You just kind of have to follow directions. It says we want to times by 3 f of 2. So first let's figure out f of 2. F of 2 means you plug in 2 to the f function. Let's do this in our heads. What's 2 squared?
4.
But then you got to double it and you get 8. And then you get 8 minus 10. That's negative 2. And you add 1.
1.
Negative 1. So it's going to be 3 times negative 1. And we're going to add it to 2 times whatever f of negative 2 is. So we plug in negative 2. What's negative 2 squared?
4.
We double it, we get 8. We plug in negative 2. We're adding 10 this time. We get 18. 18 plus 1? 19. So it looks like we're getting negative 3 plus 38. That's going to be 35. What is the domain of f? Guys, f is a parabola, right? So you can plug in any number you want to this, right? There's no restrictions. You can plug in negatives, you can plug in positive, you can plug in 0. So our domain is this. All real numbers or negative infinity to positive infinity. The problem with writing all real numbers is when you have to write anything that isn't all real numbers, you have no idea how to write it. So that's fine. Yep. I don't care if you write that, but when it's something other than this, you need to know how to write other than just all real numbers. Smallest possible value of f of x. Where's the smallest value going to be? Yeah, so we're going to have to complete square. X squared minus 5 halves plus a half. Completing the square means that we're going to have to take half of 5 halves, which is going to be negative 5 quarters. We're going to subtract 25 sixteenths, and we're going to add a half. Distributing the 2, we're going to get 2 times the quantity of x minus 5 quarters, quantity squared. And this is going to be negative 25 eighths. And this is going to be positive 1. We want the smallest possible value, so it's whatever these guys are added up, right? So that's 8 eighths, right? We're adding it to this. That's going to be negative 17 eighths. That's the smallest possible value, right? This thing's going to be positive, so the best thing you can do is make it 0. And then you'll subtract all that. So what is the range? Well, the range is going to be from our smallest value to our largest value. What is our smallest value that it can be? The smallest value is this guy, right? So it can be negative 17 eighths. And what's the biggest a parabola can be? It can go up forever, so it's infinity. Good job, Samantha. I think you learned things this year. Yeah. What do you know? Yeah. That was good. That was really good. That was good. That was clever. Nice job. All right, turning the page. I mean, I'm going to scan these and send them to you, right? That's kind of the whole thing that Hadley was asking about. Do we want to do 16-3-1? Any of these? Find g of 5. In order to do that, you need to make this equal 5. So you're going to plug in 6 sevenths. Finding the inverse? For real? Yep. So an inverse function switches the inputs and the outputs. So if you're looking for the inverse, the first thing you should do is switch the inputs and the outputs, right? That is literally the definition of an inverse. Now, in order to write this as f inverse of x, you have to get y on its own. Technically, this is the inverse. It's just a really gross way of looking at it. We need to get y on its own so we can replace it with f inverse of x. So to get y on its own, let's multiply to get rid of fractions. Distribute. Get all your y's on one side and everything without y on the other. How can we get y on its own here? That's right. And then, of course, what we're going to end up doing, and I'll write it down here because I'm running out of room, is you're going to get y equals negative 3 plus 5x all over x minus 2, because you can divide that out now, right? Because it's something times y, this times y. So here's your inverse. F inverse of x equals this. Ta-da! Look, it's like the exact opposite of what we had earlier. But don't just guess, because this one is not that obvious to guess. I have to read this. All right. Part D. It's an odd power, so it's going to look like this. Does this pass the horizontal line test? I mean, it does. That looked kind of flat. It's not. So it does. So it will have an inverse. Guess what the inverse is? Well, here's the original. The inverse is going to look something like this. So let's get y on its own.
Wait, if it's odd, that means that it doesn't have an inverse.
No, odd does have an inverse. Passes
wait,
horizontal.
yeah.
Yep. So if we add 3 and divide by 7 and take it to the 5th root, doesn't it get y on its own? Add 3, divide by 7, 5th root. Yep. What about x to the 8th?
No.
It's going to look like this. Doesn't pass the horizontal line test. It's not going to have an inverse. Think about it. When you take something to the 8th power, so like, if I say I took something to 8th power and I got 1, what number did I take to the 8th power to get there? 1 to the 8th could have worked, but also negative 1 to the 8th could have worked, right? So you can't do the inverse, because if I say I got 1, you don't know where it came from, right? There's 2 options. So nope, no inverse. This one is really funny. The inverse is going to be this, right? Now get y on its own. I'm going to times by y. I'm going to divide by x. Look familiar? It's its own inverse. $17? For sure? $17 it is. I mean, we still have like an hour and 10 minutes, guys. We don't have to rush to 17 if you don't want to. But we can always go back and hit stuff too. You want to go home and sleep? Okay. I believe the 17, no. We have no test for this, so this one's a bit thicker, right?
Are you still gonna like?
Cut it down, yep.
You said that the check sheet doesn't work, right? You said that like for this.
Here we go again.
it only says-
Put on your glasses. It freaks me out.
All right. Stop thinking about that. Please just do good work. The check sheets are done, okay? You've done all you can on the check sheets. All right, right here. F of x equals 3. That means no matter what you plug in, you get 3. So if I plug in 0, what do I get?
3.
If I plug in 1.
3.
Thank you. It's going to be a line, a horizontal line at y equals 3. Yeah. Okay, cool. For this, it's going to be a line, so let's plug in some numbers. If I plug in 0, what do I get?
4.
Cool, so 0, 4 is on this. 1, 2, 3, 4. What happens when I plug in 1?
5.
So 1, 5 is on this. Yeah, it's going to be a slope of 1 with a y-intercept at 4, guys. No matter what you plug in, you're always going to get points on this line. What is this going to look like when we graph it? parabola. So we should probably find the vertex. Vertex is at 2, 5 because they already completed the square for us. 2, 1, 2, 3, 4, 5. Is it opening up or down? Definitely up. And it's opening up normally, right? If we were to distribute this all out, we're going to get y equals x squared something, right? So it's just going to go 1 gets 1, 2 gets 4, 1, 2, 3, 4. 3 gets 9, 5, 6, 7, 8, 9. And there's your little parabola. And no, the final is not tomorrow. The final for you guys is 2 days from now. No, you guys said it earlier and it was wrong, and I just wanted to correct the record. F of x is the same thing as y. So this, we're choosing values for x. X is left or right, because it's x, right? And whatever we get out of it is a y value. So that means up or down. So if you go 1 to the right, you go 1 up. Do you see how it's going up? Right? Same thing with 2 to the right and 4 up, right? Basically, this is this. This, well, it's got to be this. This is positive, so it's this. This is negative, so it's that. Mind blown. All right, cool. Because that's just what it'll do, right? It's going to negate all your values, sending them to the negative direction. In this case, it's negative x values. Yeah. All right, turning the page. Vertical line test, should we go over it?
No.
Function, not a function. Function, not a function. Passes the vertical line test. It never hits it more than once. VLT is to tell whether it's a function. That's a function. Does it pass? No. Yes, this passes. That works. Does this pass?
No.
Thank you. Turning the page. Should we look at these?
Yeah.
F of 2. That means we need to figure out what happens when you plug in 2 for x. Well, over here, here's 2. What dot do we get? We get 2 comma what?
1.
So when you plug in 2 for x, you get 1. So that's 1. G of negative 1 is saying when we plug in negative 1 for x, what do we get?
Can I go let people in? I just want to game it on here.
Do it. I'm sure they'll want to start where we are. Now this wants to know f of 2, and then plug that into g, and then plug that into f. So f of 2, we already know what that is. It's 1, right? Cool. Then it wants to know g of 1. What's g of 1?
Why are S columns in
1, right? G of 1 gets 1.
Bye.
So if this is just 1, what's f by? What's f of 1? It's always this guy right here. It's like a half or a quarter or a third or something, right? I don't know. I'm too lazy to change the graphs. So I just change the numbers, and it always ends up going back to that, which is funny. How can we use this to graph this? We did it on the first page, yes? Right, it's going to grow. All right, now we need to check for inverses. That means we're using the horizontal line test because we're switching our inputs and outputs. So instead of doing it this way, we're doing it this way. Not going to have an inverse. No inverse. It is a function, but it does not have an inverse. Is this going to have an inverse?
No. Freak. Yes.
Is this going to have an inverse?
Yes.
What about this?
No.
No. This, it looks like it won't because you could draw a horizontal line right here, but notice this is an open circle and this is closed. So it doesn't count, so no. The bottom one?
1723.
How can we use this? What's up? How can we use this to graph this? Doesn't this give us the vertex? And then it's going to graph just like that going up. You make your little chart, plus or minus 1, plus or minus 2, plus or minus 3. Yeah. This guy, you need me to talk about this? F of 2. Means what happens when we plug in 2 to f. So here's 2. Do you see how 2 gets 1? So this is 1. What's up, Camden? G of -1 says, what happens when we plug in -1? Well, we get -1, comma 1. So this is 1. This wants to know what's f of 2. Plug that into G, then plug that into f. So let's find f of 2. F of 2 is 1. We found out that earlier. So that means we're going to do g of 1. What's g of 1? Also 1. So what's f of 1? Like a third or something. I don't know. Intermediates, quiz 17. Yeah. Boys, we're looking at 17 right now. Intermediates, if you'd like to join us, you may.
Oh, boys.
This is what we're working from. You probably already have something.
Final, we can't use anything, right?
Nope, nothing.
No.
Doing it raw. All right.
Okay.
Here.
Okay.
Y equals f of x is what we're trying to graph. So pretend that this is y and whatever. Guys, if you plug in numbers, you're just going to get a line. So if I plug in 0, I get 0. If I plug in 1, I get root 2. Root 2 is a little bit more than 1, so like 1 and change. If I plug in 2, I'm going to get 2 times the root of 2. Well, that's like 3-ish something. I don't know. But it's going to be a straight line. Slope is root 2. Okay? Here, the root is affecting the x value. What numbers can I not plug in? Anything negative. So all this is off limits. Can't plug in anything negative. So what's the smallest number I can plug in then? 0. If I plug in 0, I get root of 0, which is?
No.
Times 2 is? 0. So I get 0, 0. So 0, 0 is on our graph. Cool. What happens when I plug in 1? 2, because the root of 1 is 1, and you times it by 2, you get 2. Now, I'm not going to plug in 2 or 3 because they're kind of nasty numbers. Instead, I'll plug in 4. What happens when you plug in 4? You get 2 times 2, which is? 4. So 4 gets 4. 1, 2, 3, 4. Let's do one more. I'm going to plug in 9, because the root of 9 is 3, and if I double it, I get 6. So here's 9, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. And you can clearly see what's happening here, right? It's this little curve. Yep, that's how the square root graph do. All right, for this, what numbers are we not allowed to plug in?
0.
So I'm going to do a little asymptote here.
And what to?
Asymptote.
If we didn't do that, I would necessarily
Wouldn't you like to know? Did Reed? If Reed did, it'll be fine. But if you didn't, then it's wrong. All right. Let's plug in numbers. How about we try a number like 1? What happens when you plug in 1? So 1, 1 is definitely on our graph. What happens when you plug in 2? So 2 gets a half. It is. It's going to get real close. 3 would get a third. 4 would get a quarter. 5 would get a fifth. So it's going to go like this. What if we plug in a number like a half, though? What is 1 divided by a half? How many times does a half fit in a 1? So a half gets dose. A third would get 3, a quarter would get 4, right? It's doing this. So we got this cool little curve that's going as close to the boundaries as possible. However, we are allowed to plug in negatives, and we have nothing over here in negative land, right? If I plug in -1, what am I going to get? -1, right? If I 1 over -1 is just -1. If I plug in -2, I'll get -1/2, though, right? -2 gets -1/2. And you'll notice we're going to get the same thing, right? It's going to be the same thing. Just doing this. It's kind of funky, right? Fun little rational function. Say it again. How can you plug in a positive and a negative at the same time? This guy. Basically what we're doing is we're going to take the outputs from this and we're going to add them together. So check it out. Map out your critical points first. All the other points that you could do here are going to be between these values. Okay, so here are critical points. We've got a critical point at -4, a critical point at -1, critical point at 2, and a critical point at 4. And that's identical on both, and that's no mistake. That's to make this problem a lot easier. Because otherwise you'd have to plug in a bunch of weird numbers. Okay, cool. So basically what we're going to do is we're going to have x be -4, -1, 2, and 4, and we're going to see what happens. So when x equals -4, let's keep this organized. We get f of -4 plus g of -4. Let's find out what f of -4 is. What's f of -4?
That's 3.
That's 3. What's g of -4?
Oh, that's like negative.
That's actually -4. So what we're going to get is -1. So on our new graph, which is combining these, x was -4, and the output is whatever you add together, right?
Oh, this is double trouble?
Is -1. 1, 2, 3, 4. That's it. That's it. What about at x equals -1? Well, that means we're going to find f of -1, and we're going to add it to g of -1, because that's what they said to do. We're going to get some value, and we'll plug it in. So let's look at the graph. F of -1 is what? And what is g of -1? Positive 1. So that means overall we're getting 0. Overall we're getting 0, right? So -1, 0 is on our new function. What about when x is 2 at x equals 2? Well, that means we're going to get f of 2 plus g of 2. And our coordinate will be 2 comma something, right? Looking at the graph, what is f of dose? It's 1. G of 2 is also 1. So 2, 2 is on our new graph. Uh-oh, they're packing up.
Ew. Why's your face like Mr. Mac, here's the 17 back. I didn't write on it.
Thank you.
Can I take the quiz?
No. Just take the final tomorrow. Stop being such a baby. You're worried about it? So let's find f of 4 and g of 4. F of 4 is 1. G of 4 is -2. That means when we plugged in 4, we got -1. So 4, -1 is right here. And that is the last... Oh, no, it's not. Is it the last of our critical points? We did 2, 4, -1, and -4? Yeah, yeah. So now we just connect the dots. And that'll be what our function looks like. All of the dots that we didn't check, like in between, right? They're just going to fall in between these guys. So there you go. There's the new function after you add the outputs. It's just a little guy. All right. That's page 6. Page 7. I think it's a yes, right? Guys, if this is the original function and we want to find the inverse, what do inverses do?
Flip the input and output.
So let's find some nice points that we can flip the input and output on, and then just put them over here on this graph, right? So this guy is -1, 2, 3, 4, -5. Bye. This is 0, -4. This is 2, -1. And this is 3, 1, 2, 3, 4, 5. It looks like it's like 3, 5. So on our inverse, which is what we're going to graph over here, we're just going to flip all those. So 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. -1, +2. 0, -4 becomes -4, 0. 2, 3, 4. And -5, -4. So -5, 1, 2, 3, 4. So here's our curve. That's the inverse. Something like that. 5, I was really struggling with this the other day, so let me double check. 5, 3, -1, 2, -4, 0, -5, -4, yeah. I mean, I didn't, but it's going to fall on that, right? So basically, I just picked a bunch of points and then connected the dots, right? We know it's going to be smooth. It should be, yeah. Yeah, it was on this, right? Yeah. So 3, 3, 3, 3 is 3, 3. Yeah. So look, right there. Yeah. Yep. No, that's cool. That's cool. All right. Turning the page. If you know what this means, it's really easy, and if you don't, it's really, really hard. So we're going to do the same thing we did earlier with the critical values. This is -4, critical value at -1, critical value at 2, critical value at 4. And we're just going to move all those dots and connect the lines. And by move them, I mean we're going to do whatever it says here, 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 and here. So when you have a 2 inside of here, it allows you to get away with smaller x values. So for instance, we used to have to plug in 4 to get this dot, right? Yeah. But that's going to double it for us. So in order to get 4, we actually got to plug in 2. So 2 is now going to get us 1. This dot becomes 2, 1. So let me color coordinate this. This dot right here is now going to be 2, 1. Right there, that's a 2, 1. We used to have to plug in 2 to get this other dot, but now we got to plug in 1. So now 1 will get us 1. So 1 gets us 1. World's smallest graph, I'm sorry. -1 used to get us this dot. Now -1/2 is going to get us this dot. So -1/2 gets us -1. World's smallest graph. I am so sorry. Oh yeah, and this guy's the orange guy. And then if I choose brown. -4 used to get us this color. Now -2 is going to get us this guy, right? So -2 is going to get us 1, 2. And then we just connect the dots. Notice it's the exact same graph. It's just shrunk horizontally by a factor of 2, which is exactly what this does. It shrinks it by 2. Or grows it by 1/2, if you want to say that. All right, this guy. We used to be able to plug in 4 to get what we wanted. Now what are we going to plug in? Yeah. Yeah, but we don't know what f of 7 is. We don't have that over here. Yeah, so x needs to be 1 now. Do you see how I used to need 4, right, just to plug it into the original. Now I need only 1. So I can get away with smaller x values. That's going to move everything to the left. Smaller x values are towards the left. So yeah, it is going to move it all 3 to the left. So just real quick so we understand what's going on here. It used to take 4 to get this dot. Now it only takes 1 to get that dot. So 1 gets 1. That's here. 1 gets 1. It used to take 2 to get this dot. But we're going to add 3 for free. So what do we add 3 to get 2? -1, right? So -1's going to get 1. And you'll notice that just moved it over 3, right? Moved it over 3. All right, used to take -1 to get this dot, but now we need -4 to get that dot. So that's going to be the orange dot is moved over 3. So -4, 1, 2, 3, 4. And then this guy is at -4. Well, we need -7 to get that done now, right? So we're going to plug that in. That's here at -7, comma 2. Notice this is the original graph. It's literally just shifted 3 to the right. So don't memorize what these things do. Think through it, and then once you know that's how it works, then you can move it up, down, left, right, etc. Shrink it. This guy, we know from the last one that this moves everything to the right 3, right, or to the left 3, yes? And then it's going to double our outputs. Our outputs are our y values. So everything's going to move to the left 3, and then we're going to double everything. So it's going to be at 4, that's going to be at -2, that's going to be at +1, that's going to be at +2, that's going to be at +2, okay? So let's do that really quickly. I will, there's not a great way to keep all these together. There is not. I will zoom out and then I'll zoom back in, okay? So we know it's going to move everything to the left, 3, so that puts it at 1. Instead of being 1, 1, we're going to double that to 1, 2. This next dot, we're going to move it left 3, and then we're going to double its output, so it's going to be 2, so -1, 2. And notice what was like horizontally connected before should still be horizontally connected after, right? All right, then this guy, if we moved it left 3, that's what this means, and we double its output, well, it used to be -1, now it's going to be -2. So we're going negative 4, 1, 2, 3, 4, minus 2. And this last dot, it's going to be negative 7, double the output, 4. Negative 7, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And then it's going to be 4. 1, 2, 3, 4. Same thing, just moved left 3 and doubled its output. So it's like a vertical stretch. This guy. What this is, we already know that it's going to shrink it this way, so it's going to give us this, right?
Yeah.
If we add 3 when we're done, isn't that going to move everything up 3? Right? So it's just this guy, but everything's up 3. So I'm actually going to look at this guy. It used to be 2, 1, but now it's going to be 2, 3. That used to be 1, 1, but now it's 1, 3. That used to be negative a half, or no, yeah, negative a half, negative 1. But now it's going to be a negative a half, positive 2, because we're going up 3. And this last guy used to be negative 2, 2, but now it's negative 2, 5. Yeah, thank you. Sorry, I was like, did we already factor that in? Yes, we did, because it's coming from that. Cool. Forgot what I did earlier. Yeah, I know. Annoying. That might be one of the hardest ones, honestly. It's just so easy to get messed up. This next one is not that bad if you know what you're doing. All we know is that g of 5 is 3. That's all we know. You plug in 5, you get 3, right? Oh, she's packing up. She's packing up. That's it. She's out of here. So, do we need to go over these? Because it's just you two. Yeah? Okay. So, if only this were g of 5, we could say it equals 3. Nah, I'm going to do them anyway because it's recording. How do I make this equal 5? 5 halves. And now we get g of 5, which is 3. Bye. Here, I wish this was g of 5, so I'm going to plug in 12 to make it g of 5, and g of 5 is 3. Here, I can just plug in 5 to get g of 5, which gives me 3 plus 5, which is 8. We feeling okay about that?
Oh, wait, sorry. How did you see?
Well, how do I make this g of 5? You just plug in 5, and g of 5 is 3. 3 plus 5 is 8. All right, here. If only I could make this g of 5. I can. I'd plug in what? 10, and then I get 3 plus 3, which is 6. If only I could make this g of 5. I can. Just plug in 5. You get 20, right? If only I could make this g of 5. Well, I need this to be 12 minus 7, right? So that's going to be 4 when I plug it in. When I do that, I get 3, right? Because that's g of 5. I get 3. 3 times 2 is 6. 6 plus 4 is 10. Again, really easy if you know what you're doing. You keep your head on straight. Okay, this next one. It's saying if I move everything to the left 3, right? From here to here. Can they intersect? Here's my curve. If I move everything to the left 3, it will not intersect. Okay? Ooh, actually, hold on. If this is a flat line here, it totally could, right? No, it would be above it. No, wait, left? If it's left, it can. It can. It definitely can. Yeah, it definitely can. Because it could do this, right? You know what I mean? So the answer is yes. But this is moving it up. So if I take that same curve and I move it up, it's never going to intersect, right? They're always going to be above each other, directly above. So this one is no. This one's really silly. Like, we know what happens if we put a number in front of here, right? It's going to stretch everything. So if you put like 5 in front of it, it's going to stretch everything 5 vertically. If you put a half in front of it, it's going to shrink everything by a half vertically. What if we put a 0 in front of this? Well, then we get y equals 0. What's that going to look like? Give me a point where y is 0. Give me another point where y is 0. Yeah, so if you do this to your function, if you put 0 in front of it, it just flattens it to this horizontal line. All right, so this one, we want to draw the graph. Hold on. We did this earlier. Hold on. No, pause. This one isn't asking for the graph. This is asking for what f of negative 1 is. Well, if you look, f of negative 1 is 2. That's why I included the graph originally, because you can like graph the whole thing and then give yourself 2. But you could also figure that out over here, right? If the inverse takes -1, it's going to pop out 2, right? This one actually wants you to graph it, which we did earlier, essentially. Okay. 0, 0 is going to be on it. 3, 2, 2, 3. You get the idea. Should we do any of these or no? Yes? Spicy? What property must the graph of f of x have if f of x equals the inverse of x? Okay, cool. So basically it's asking, like, when will the inverse be the same as the original function? Well, earlier we saw that if 3, 3 was on our graph of the original, it'll also be on the old one, right? So it's got to have this property, right? So it's got to have, like, every x and y be the same. So to have that, that means it's got to look like this, right?
Yeah.
1, 1, 2, 2, 3, 3, 4, 4, etc., right? It's got to be this. Why is it true that f is a function such that no horizontal line passes through 2 or more points and f must have an integer? So basically we're asking, why is the horizontal line test true? Well, here's my general explanation. If something doesn't pass the horizontal line test, that is because we have coordinates that are like this. We have some x value and we have a y value. We have some x value and we have the same y value as before, right? They're the same height. And then we have a different x value. This one's further to the right, but it has the same y value. So that's the original function, right? And it clearly doesn't pass the horizontal line test. Do you see if I flip these, I have the same input getting us different outputs? That's not an inverse. You see what I'm saying? You plug in y to the inverse, you get 3 different answers. Y gets all of these when you invert it. Does that make sense? So horizontal line test is just showing you that, look, if you were to invert this, you're going to get 3 of the same things getting you different things. It's not a function, right? So put that into words somehow, draw a picture, I don't know. I'm going to be pretty lenient on that for the 2 that are here. This one right here?
Yeah, it almost looks like a
How come? I don't know yet. Let me just double check to make sure we're not goofing. 3, 2 becomes 2, 3. And then 4,
never mind.
5, 4. I think you drew it wrong.
The negatives sort of move it to the right.
Just hold up. This is -1, 0. So 0, -1 is on here. And then this is -3, -2. So that's -2, -3. Yeah, it's going to end up looking like this.
What was the point you just did?
-2, -3. So this is -3, -2. So you're going to have -2, -3.
I just did it right on negative signs.
Yeah, I figured that was the case. 1, 2, 3, 4. -5 means we're going to get -5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So yeah, it's going to be like this.
I just skipped the negative sign.
Yeah.
A little spicy, that's it?
Yeah, that's it. So that's 10 out of 10 if you can get all the ones there. So yeah, as per usual, Esteban, especially if you're here, like, you're going to crush this final and your grade's going to go up a ton, which doesn't teach you the lesson I wish I could teach you, but when you're good, right? All right. That's 17. Boys, we got 30 more minutes. Do we want to run back and talk about 16, 15, 14, or
I just have
12, 13?
I'm good. I'll be fast. I'll be back. You want me to read? I don't
I would definitely watch the video from earlier if, right, because I'm telling you, some of that stuff on 12 and 13, you're going to be like, oh man, I forgot how to do this, and it's really easy.
Final, like 12, 13, 14, 15, 16, 17.
16.4.2. It has, I know it has an inverse, but it's got an odd D.
Here's the original.
So you,
Inverse means switch x and y. Add 3, divide by 7, take fifth root.
you root everything. Is it okay if I just put x on the denominator over x to the fourth? I think is what I did on it.
No. I mean, I'll look at it. Maybe you did something super weird that works out, but probably not.
So because I thought since it was repeated multiplication, like exponents are repeated multiplication. So
You divided by x 4 times.
So, yeah, so
That's fine, but you have itself in the definition. You know what I mean? Right? So, like, you have...
You have x in its definition right there.
No. Well, maybe, I don't know. I'll look at it. Because you do want y on its own, so maybe you're fine. But I don't think so.
I have,
Oh
like,
my god.
I think I ended up with like y equals, and then it's like.
And no,
blah,
he-
blah,
and here's
blah.
and here's why. Because you have to fifth root all of this, not just the x.
Yeah.
Right?
Can I show you what I would do real fast?
Yeah, this is gonna be awful. I like how you thought, though. That was at least thinking. That's good. Alright, while you're doing that, I'm gonna start printing all these, because nobody's gonna have them. Everyone's gonna be like, I don't have any of these. It's gonna take 30 minutes to print them all. You got Algebra 1 coming in.
So this is how I would do it.
Okay, I'm ready to be amused. Okay, so that's the switch, and then you added 3 and divided by 7, and you're dividing by y to the 4th. So yeah, here's your problem, okay? It's doing the thing I thought you were doing. Do you see how this leaves y behind, and you're using it in its own definition?
Yes.
That's not okay. You can't say, in order to know y, you just need to know y.
So I got that wrong.
Yes. Mm-hmm. Yeah, you have to have y completely out of there. So clever, but no. Points for clever. Imaginary points, of course. I will laugh at it later, though. So there's that. Like, I'll see it and I'll chuckle.
Oh, I did it for a lot of them. And then, so for f, it's its own inverse. So should I just, I didn't even write like a yes or no.
Is
I
f
said
actually its own inverse, or you just think it's its own inverse?
No, it is. Like you have it right there.
Oh, this one?
Yes.
Yeah, that's fine.
I didn't
That's
write
fine.
yes or no, I just wrote inverse.
I thought you meant this one, because this one sometimes is, but in this case it wasn't, right? So, yeah, you're fine for f. You're fine for f.
And then, can you do 16, 5, 3, and 6, 4? Those are the ones that I also wrote.
16, 5, 3, and 16, 6, 4.
The last two.
Yep. Mm-hmm.
Only two I don't know.
Okay, so check it out. We really want to know f of x, and then we're going to times it by 3. Okay, so first we should probably find f of x, right? This is f of 5x. So what can we plug in? A fifth x. If you plug in a fifth, you're going to get f of a fifth, and that's not what we want. So you're going to plug in a fifth x. Kooky, right? That's like super weird, but it's true, because that gives you f of x, right? So what happens when you plug in a fifth x? Well, you're going to get 1 over 4 minus 1/5 x. So f of x is this, right? That's what that is. But we got to times it by 5. So that means we're going to do 5 times this bit of shenanigans. And here's what everybody really wants to do. And that's why I always make this a 5 here. Or, well, I always make it... You're always going to get this number reciprocated, right? And it makes people want to times 5 top and bottom, which you can do. But if you times by 5 top and bottom, what are you really multiplying by? 1, and that's not what it has to do. So if you want to times by 5 over 5 to get rid of that fraction, knock yourself out, right? But to times by 5 like they asked to, you just times the top, man. So there you go. If you want to first times by 5 over 5 to get rid of this fraction, you can. And then you'll get 25 over 20 minus x, which is definitely something I'd rather work with if I had more work to do. But I don't. I'm done, so I'm just going to... Please. Please. You're done. Who cares? You know my rule about simplification. It's for you, not for me.
Wait, but we still have to have 3 after. You did 5. But it's okay.
So, yeah, normally I try to make these guys match. That's what I was trying to say earlier. Okay, so yeah, you'll do 3, not 5. Thank you. So that's 3. This is 15.
Yeah, I also want to stay there.
Yeah, my bad.
And then the next
That's
one,
what I was trying to say.
I think I did it right today. So you have x cubed plus y squared.
Yeah, it says first we're going to HH. So to HH, you have to cube H and then add H squared. Okay, cool. Then you're going to take this and you're going to H it again, or question mark it again. So to do that, the first thing gets cubed. Okay, cool. So this gets cubed. and then you're supposed to add it to whatever the second thing is squared. So it's this guy
I didn't use H's today.
squared.
I left this X in mind.
Here's the next mistake everybody makes. They say, oh, that's h to the sixth, that's h to the fourth. What does it mean to square something?
You're gonna have 3 things.
You are going to have 3 terms. You got to times it by itself, right?
They're
H cubed times h cubed is h times h times h times h times h times h. Read, this is not h to the 9th. It's h to the 6th. That was a shout out. H cubed times h squared is h times h times h times h times h. This is clearly h to the 5th, not h to the 10th. You're going to get the same thing here. You can combine those in a second. And then we're going to get h squared times h squared, which is coincidentally h to the 4th, no matter how you do it, right? So we're going to get h to the 6th plus 2h to the 5ths plus h to the 4th plus h cubed if you write them all in descending order. I don't care if they're descending or not, though. You could have circled this after you combine those terms. So, fun fact. See how there's 2 of them?
Oh, wait, actually.
I wrote it in descending order, yeah, because
Why is your H 108 become this? Because your first H, never mind.
yep, we're just adding.
Because whenever you do it again, and then like, it's H to the 3rd, and then like the other thing's going to square.
Yeah, sure, why not?
Because
Yeah.
you have the question mark, and then the question mark becomes a 3 because you're putting it in, and it's.
Yeah. We're doing this to the first thing. Yeah. Yeah, functions are a bit of like a, yeah, I don't know what the word is. It's a little trippy, right? It's a lot of thinking about stuff like that. Calculus is the epitome of trippy, where you're like, okay, we're inside a thing. How does this work? All right. Anything else we need?
No.
Nothing from 15. Nothing from 14. Nothing from.
Good. Oh wait, did you see my email I sent late last night?
Probably not. So you sent me stuff and it was late and it's in now?
I sent to do it at like 9 o'clock because I said it was 9 o'clock. I sent it. I didn't figure you were gonna do it.
I wasn't. What? But it was due at midnight, so you were fine, right?
Old like 10:15, but I attached it onto my 16, 17 trace sheet because I'm like, I'll just do this, and then I'm like, since it's taking away, I'll just do it.
Okay, cool. Then we're fine. If it's in my email, I'll see it and we'll be good.
Okay.
You guys are sure you don't want to go over any of this stuff?
I have all the basic stuff.
You aren't worried about solving a problem like this, where it's already completed the square and we actually have to solve?
No, I wasn't gonna do it.
Okay.
Positive, negative,
It's got to be 3 minus 3. What do you square to get 3? This. But it's going to minus 4. We don't want that, so we'll put a plus 4. See how if I plug this in, it subtracts 4. We square it, we get 3 minus 3. We win.
hey, why'd you get this? I'm kidding.
No, it's good. All right. Peace.
Thank you.
Later. All right. End video transmission.